Hey, what's up, y'all? This Sasquatch with Full Throttle Quads RT, and I'm going to teach you guys how to do a couple of different essential math problems that you should be doing before every build to determine what size battery you need, what size ESC you should be running, and the total weight that your quad will be able to carry with the components that you're using. So first, let's take a look at what size battery you should be running. So I'm running Tiger Motors MT2212-16 750 kV, and I'm running that on my S500 build that I'm doing right now. So first, what I did was I pulled up the spec sheet on the Tiger Motors website of my specific engine motor, and we need to figure out the total max continuous current that these motors can handle. So we find out right here. Max continuous current is 16 amps. Sorry about it's not too clear. It's very blurry, I'm sorry. So 16 amps. So what we want to do then is we want to take that as 16 amps and we want to times that by the number of motors we have. So I'm doing a quad build, so it's going to be 4. So the total is 64 amps. So we need a total of 64 amps to run my quad at its fullest potential. So what you want to do is you want to take your battery. This is not the battery I'm using. This is just an example battery. So what you want to do is you want to take the total number mAh times C equals your amps. Okay. So what we want to do here is it's a 5. It's 5,000. So it's 5. So we're gonna do 5. I'm gonna do it by the lowest because that's the 20 is your continuous discharge, where 30 is just like a burst, like a 10-second burst. So we're doing 5 times 20 equals 100 amps. So obviously this battery is way too strong for what I need. So what I would want, what I need basically, is you want to take 64 amps. That's your max amps that you need for your quad. And basically what I need is 20 or 2000 through 2200 mAh battery running at a 30 C discharge, 3S LiPo. So what that would be 2 times 30 equals 60. So that's about, or 22, 2.2 times 30 equals close enough. I don't even know what that equals. Sorry guys. Whatever. 2.2 times 30 equals total amps needed. So my ideal battery would be a 2000 to 2200 mAh 30C 3S. So that would be my, like I just said, my ideal battery range. Okay? So real quick guys, so what you want to do, one more time, figure out your max continuous current for your motors, which was mine was 16 amps, times it by the number of motors you're running, equals your total amps. Then you want to take whatever battery you're using, or just figure it out in your head. So if you have batteries laying around, such as this one, you take it 5 times the total discharge rate, which is the C number, so it's 20 equals 100. So like we came up Like we decided this was too big of a battery, even though it's a 2 cell. So what we decided on was I needed at least a 2000 to 2200 30C3S would be my ideal battery range. Next, let's take a look at how we determine what size amp or what size ESCs we need for our quad build or for our multi-rotor build. Once again, you want to figure out your total max continuous current, which is 16A for my size motors. And you want to times that number by two magic numbers. Those two magic numbers are 1.2 and 1.5. Those are your two magic numbers that you need for this build. So you want to times those numbers, figure out the total, and you will want to take the mean of those two numbers to determine the size of the amps or the size of the ESCs that you need. So I need to do 16 amps times 1.2 so 16 amps times 1.2. My total is 19.2. 19.2. Next we want to do 16 amps times 1.5. So 16 times 1.5 is a total of 24. So I need to be somewhere between 19.2 and 24. So I determined that my best choice would be a 20 amp ESC. Alright guys, so real quick, one more time. So we need to do max current times the two magic numbers, 1.2 and 1.5, and then we find the mean. We find the best ESC that fits between those two numbers. So this is really just simple math, but it's going to make all the difference when building your quad. So next, we want to figure out the total weight that our quad can pull or lift. So what we want to figure out is what our max thrust is with the motors that you've chosen. So let's go back to my spec sheet. Oh, I'm sorry, it's down here. It's in the grid. So there's actually a few different factors, and luckily T-Motor has broken this down for me. But these are my motors right here, the MT12 or 2212 kV 750, and my max thrust for these are 940, but that's with an 11 by 3.7 degree prop. I'm not using that size of prop. I'm using a 10 by 3.3. So that makes my max thrust 540. 540 is going to be my max thrust. Next, you want to take that max thrust and times it by the number of motors you are running. I'm doing a quadcopter, so minus 4. So I'm doing 540 times 4, and that is what 2,040. So 540 times 4 equals 2160. 2160. And then now we want to divide that by 2. So 2160 divided by 2 is 1080. So now we want to divide by 2 equals 1080. So my total weight needs to be under 1080 with the props that I'm running. Now, if my quad ends up being over 1080, all I have to do is use a bigger prop. Because I'm pretty much at the bottom spectrum of these props right now. So I mean, I have a lot of room to grow with these props. So really, if I wanted to, I could do 940. If I wanted to run 11 by 3.7 prop, my max thrust would be 940. So once again, I want to do 940 times 4, number of motors I'm running. There's 3,700, or I'm sorry, 3,760 times. So it's 940 times your motors is 4 equals 3,760. Next, we want to divide that number by 2. And that is 1880. So 1,880 grams. So that is my total weight that I need. I cannot exceed this number with my motors. This is my magic number. No matter what prop I use, I cannot exceed that number. Alright guys, so one more time. To figure out the size battery that you need for your components, you want to know you got to figure out, you want to find the spec sheet for your motors. You want to figure out the max continuous current. Mine was 16, so we times that by the number of motors we're running, which was 64 amps. And then we decided that I needed a 2,000 to 2,200 mAh 30C. So what you do is you take the number. So this is a 5,000. So you take the 5. So it's a 5 battery. And you times that by C discharge, which is 20. It's always the lower number. And this came out to 100, which was too big for my quad. But we decided that a 2 times 30 is 60, which is close to where I want it to be. Okay. Next, we figured out what size amps we need, or what size ESCs we need. So once again, we need to figure out what our max continuous current for the motors were, and that was 16 amps. So this one, there's just two magic numbers. Where these numbers come from, don't ask me. I just know the equation. It's 16 amps times 1.2 and 16 amps times 1.5. And then you take the mean of those two numbers. we decided that 20 amps was the best ESC for my quad build. So it's amps, max continuous current amps times 1.2 times 1.5. Next, we figured out the total weight. What we needed to know with total weight was a little different than the previous ones. We needed to know the max thrust, which for mine, luckily T-Motor broke it down by different size props. And I was to figure out that I needed 540 max thrust, or 540 was my max thrust. We times that by the number of motors I'm running, which was 4, equal to a total of 2160. And we divide that by 2 to come to the final number of 1080. So 1080 is the total weight that I can carry using the props and the motors that I'm running right now. If I wanted to go bigger, I could take it to the farthest end of the spectrum, which was 940. So times that by 4, which is 3,760, divided by 2, equal 1,880. So this is the absolute max I can do with with the biggest props with the motors that I'm running. I cannot exceed this number, or else my quad will severely lack in performance. Well, guys, I hope this helps you decide what components you need to make your quad run at the maximum performance. Well, thanks for watching. Don't forget to like and subscribe, and stay squatching, my friends.